Hey, hello and welcome to today's GFG problem of the day. Hope you all are doing well. So let's see what the problem is. Remove k digits, right? So what the problem is saying is that we'll be given a string, okay, and we'll be given a k as an input. So now what we need to do is we need to remove k digits from the number, right? From the number so that the new number is the smallest possible. Okay, okay. So here, if you see this example, right, the numbers, the three digits which are removed, right, k equal to 3 which are removed are 4, 9, and 8. Okay, so these are the biggest number if you see, right? These are the biggest number among all the numbers in the string. Okay, to form the new number 111, which is smallest. Okay. Hmm. So and also the expected time complexity and space complexity is O of n. Okay, O of n. Now what we can do is let's directly come to the intuition, right? So 1, 4, 9, 8, 1, 1. Okay. So what we can do is we can have a stack. Okay, we can have a stack, and what we'll do is we'll start iterating each character or each number, right, from the start. So let's push this 1. Okay, we pushed 1. Now the next number comes, right? The next number comes, we'll push this 4. Okay, 4. And then the next number comes 9, we'll push 9 as well. Okay, and then the next number 8 will come. Now when 8 comes, we'll check, right? Whenever we insert each element, right, whenever we look to insert the element into the stack, we'll check whether the top of the stack is greater than the current element, right? What is the top of the stack? It's 9. What is the current element? It's 8, right? So 9 is greater than 8. So we are going to remove this. Okay, okay, we are going to remove this. So we will remove uh, 9 and we'll put 8. Okay, we'll do this operation until for example, now let's see the next example. Okay, now we inserted 8. Okay, now we come to 1. Okay, now we'll again check whether the top of the stack is greater than 1. What is the top of the stack? 8. And what is the current element? 1, right? So it is greater. So we are going to remove this. Okay, so we'll keep doing this operation until the top of the stack is we'll keep doing this operation if the top of the stack is greater than the current element. Now 8 we removed, right? Now it is 4. Okay, and 1, right? So 4 is greater than 1, so we are going to remove this as well. Okay, so now the top of the stack is 1, right? Right, and so we'll push, right? Both are same, so we'll push 1. Okay, and then again we'll process the next element, and so the top of the stack is 1 and the current element is 1, so we'll push. So what we are going to do is we are going to remove the elements when the top of the stack, right, when the top of the stack is greater than the current element, and we'll keep doing this until less like the stack is not empty or k is greater than 0. We'll do this operation only when k is greater than 0, right? So k should not deplete, right? If k is 0, then we won't remove the stacks, we won't remove the elements anymore. Okay, so this is the intuition, right? And also one more thing is the given number does not contain any leading zeros. Okay, the given number does not contain any leading. So for example, so the final output should not be like 0, 0, 1, 1, 1. Okay, we have to remove these leading zeros. So yeah, so for example, let's take this case, right? For example, if the given digit is something like, right, this 9002. Now what we'll do in the stack, we are going to push 9, right, first, and then we'll process the current element, which is 0. 9 is greater than, top of the stack is greater than the current element, right? So we will remove this. Okay, but at the same time, now we don't have any element, right, in the stack. We don't have any element. So at the same time, we won't push this 0. We won't push this 0 because we don't want leading zeros, right? We would have only pushed this 0 if like the stack would uh, like if it would have contained some element, right? Okay, so we won't, when the stack is empty, we won't put the 0, right? So as to avoid the leading zeros in the answer. Okay, so let's quickly see the code. So here is a code, right? So we are taking stack here. This is Java code, sorry, this is C++ code. Okay, let's iterate through C++ code first. Okay, so now we are iterating through the string, right? And then we are checking here with whether if the stack is not empty and the top of the stack is greater than the current element, right? The current character, and k is greater than 0, then only remove the elements from the stack and decrement k as well. Okay, decrement k as well. Then here we are checking, right? If the stack is not empty, right? If the stack is not empty and or c is not 0, right? Then push the element. Okay, and then what we have here is like once we are done iterating all the characters, right? But still now k, like k is still not, k is non-zero yet. Okay, k is still non-zero. So what we'll do, we are going to remove the top elements, right? The top elements, right, until k is 0. Okay. And then what we are doing here is, then once we have removed the k elements, k characters, right? Then we are iterating through the stack and creating our result, right? And then simply uh, we are reversing that, because stack, right? First, last in, first out, LIFO, right? It follows. So we have to reverse the string and then return the result, right? Similarly, if the result is empty, right? If the stack was empty, so we simply need to return zero only. Okay. So this is a solution. Let's submit it. Okay, so it is passed. Let's quickly see Java code as well. So here's the Java code, right? Again, we have taken stack here. We're iterating through the characters, right? We're popping out the elements when if the stack is not empty and the peak and the top of the stack is greater than the current character, right? And k is also greater than zero, right? We are popping off, and then we are also decrementing k, right? Here we will only push non-zero element, right? In the stack. We'll only push non-zero element in the stack. Okay. Okay. And then here what we are doing is, if k is still non-zero, right? If k is still non-zero, right? So we will pop the elements, right, from the stack until k is 0. And then we are taking string builder. We are pushing the characters in the string builder. And if the length of the string builder is 0, we'll return 0. Otherwise, we'll reverse, right? So yes, this is a solution. I hope you have understood the solution. Please subscribe to my channel and like the video. Thank you very much. Have a happy, healthy, and a great day.